Well, hello everyone. Pleasure to be here today. I've had the great opportunity to be at the Energy and Mine Conference in Chile this past, I think it was April or May, and we had a similar discussion where the challenge of the mining industry, especially in Chile, was quite obvious and is still quite obvious. They are looking for options, energy options. They're looking for approach to having an energy solution that is tailored to their needs. And the market is there, the projects are there, the energy is there, the opportunities are there. It's just a matter of making the match, right? And hopefully today with the great panel, I mean, I think some of you have had the opportunity to listen to these fine presenters, and hopefully today we'll have a very interesting discussion over what are the possible solutions in integrating energy solutions, but above all, renewable energy solutions. Maybe without, I'll start by introducing my panel. I just have to take my notes. Sorry about that. So Tony. So on my left-hand side, I have Tony McCook. Am I pronouncing? McCooch, I'm sorry about that. President and CEO of Lakeshore Gold. Tony has over 25 years of management and operation and technical experience in the mining industry and has dealt with projects in Canada, the United States, and has worked with companies such as FNX Mining Company. I was looking at earlier on at the panel list, and I think you may know Catherine. No? Have you? Yeah, I would assume so, yes. And also you've worked at Dynatech Corporation. So welcome, Tony, and hopefully we have a great conversation today about energy solutions for the new mining operations. On his left, we have Richard Spencer. No, sorry, excuse me. Jared Lasserson. I'm very sorry about that. Jared is the CEO of MGX. I can't see them. Yeah, here we go. MGX Minerals, over 20 years of experience, Jerry has, with Osprey Systems, United Helicopters, you've worked in the past, and Copper Island Mines, is that correct? As well as Manto Resources. Am I correct in saying that? Yeah? All right, so welcome to the panel. On his left, I have Catherine Farrell, CEO and Director of TMAC Resource. You have more than 25 years of experience with work experience at KGHM, great big international mine. Quadra FNX Mining, that was formerly, I think, the mine, the KGHM. QUX Inco Limited, Ontario Geological Survey. And you're a professor at Laurentian University, right? So what? Adjunct professor at Laurentian University. And last but not least, Richard Spencer, CEO of U3O8 Corp, 20 years global exploration experience in South Africa, I understand, and also in South America, in Ecuador specifically. You've worked for Crystalex and IAMGOLD Corp. So thank you very much for joining me today. I think and I'll start by asking Catherine. I think in general there are many energy solutions available for the mining industry, and I'd like to have your point of view. What are those energy solutions that you're looking at when you're looking at energy solutions for your mining industry and your projects?
Yeah, we're an Arctic mine, and you know, it was interesting 2 sessions ago to hear about some of the remote mine challenges, and certainly we've heard some other Arctic producers provide their points of view. We're kind of in a slightly different scenario, although we're putting a new mine into production and looking at 2 others down the road over the course of the next 6 or 7 years. A lot of our infrastructure, our starting infrastructure, is in place, and we operate off diesel, and that is already in place. So it's not what we're looking at are diesel or energy consumption from 2 approaches. One is diesel consumption, reduction of that, and then displacement of reliance on diesel, which we've heard a lot about, and obviously is one of the main topics of this particular session and a couple of the others. And so we are looking at some long-term ways of, first of all, reducing our energy consumption. And one of the main things, and this is more along the lines of philosophically changing the way that you do things in mining. We have taken an approach. We are a single commodity mine. It's gold. We have a lot of gravity recoverable gold. Some of the things we're looking at, because crushing and grinding, of course, consumes a third of our power, is looking, and it does in most mine environments that have milling. It's always about crushing and grinding. We've increased our primary and secondary crush sizes before we go to gravity, and we've also installed, or we are currently building a low-profile milling operation. The maximum height of our mill building for a 2,000 ton per day plant is going to be 20 meters. So very low wind profile, those kinds of energy savings that we're rolling through our model. And that in itself, obviously we do the glycol. We heard about Raglan does a lot of their heating with waste heat recovery from their generators, and we'll be doing the same thing. The other thing is around mining. We built a lot of flexibility into our mill. We know that in narrow vein mining, our mill is pulling production, but we built a lot of flexibility into the mill to handle manageable variations in throughput. And so a couple of, we've actually got 2 separate lines with respect to crushing, grinding, gravity, and flotation, so that we can tweak the system to reduce throughput and take advantage of higher grades. Because one of the other things for us to look at reduction in diesel use and energy use in general is the less we break, the less we crush and grind, the less we drive up ramps, and that kind of thing. So it's really that kind of philosophy we have been able to influence since we took on the project. And then now we're looking at other things such as energy storage both for insurance purposes to ensure a constant load, and we're also looking at increasing the efficiencies of our diesel gensets. But now is the time to start looking at some of our other operations. Obviously, we're in the Arctic, and solar is not an option for us, but wind is an option, and certainly we are in a very windy location. I hearken to the map that Richard showed. We'd be in one of the red zones as well. We're right on the Arctic Ocean. So those are some of the things that we're looking at.
So I listened to this, and I see two very important issues or factors to you, cost and availability, right, for your mine operations, and that's actually very crucial. And I would ask Tony, what is his view on this? Are those the 2 drivers when choosing and looking at the energy options, the cost and the availability for the mine? Are those the 2 main drivers leading in your decision?
For sure, cost. Got to be a main driver, and we're trying to be as cost efficient as possible. But you got to also recognize or realize that reliability is very important. And we're spending a lot of money constructing a mine or an operation. Catherine mentioned about building a mill, bringing a mill even to that location where they are up in the Arctic. But you're spending a lot of money getting there up front. The last thing, it's nice to try to save money on your cost of power, but you got to make sure you have power, because that's one of your main inputs you need to get the gold poured out the door. So we put as much emphasis on reliability as we do on cost.
You've talked about biomass before, Jared. Can you relate to these thoughts through your biomass operation?
One thing we've really focused on is somewhat different than traditional copper gold is that in our operations we're dealing with a quarry style similar in essence to a gravel or cement, so that we have the opportunity to actually move our ore significantly further than would exist in a traditional operation where you're into relatively low grade per ton. So we're going to remove, at least our plan is to remove essentially 100% of the ore and truck a fair distance. There's a rail line about 18 kilometers away, but we're looking at trucking upwards of 150 kilometers initially. So the question really is to do with moving the fuel sources. With biomass as well, the big consideration is how far we have to truck the biomass. So I think one thing in the biomass equation, these cost issues, capital cost, operating cost, are huge. The upfront capital cost that everybody's talked about is a real potentially stumbling block, although I think we all recognize that that fits within the financing scenario. So if the financing is there, and I will throw something out as far as my understanding of biomass, is that the Canadian government has substantial credits in place, upwards of 50+% for these types of power plants. So with support of government, these major stumbling blocks or issues begin to at least get somewhat mitigated. But like I said, our scenario is somewhat unique in that we really model ourselves on bringing the ore to the infrastructure as opposed to the other way around. But again, with biomass, just as with any fuel source, you still have to get that to the plant site. So one thing that we're watching very carefully here is not moving too much around. So moving the ore to the plant site, then moving the biomass to the plant site as well. So that's where we begin to tie into the similarities that you just don't want to be moving essentially with larger copper gold operations, you're moving a lot of dirt. In our case, we don't want to be moving our fuel in terms of biomass, but the considerations I think are identical, no different than any other alternative energy, capital cost versus operating cost. But I think the excellent point about stability of power, we just concern ourselves again, if we're moving all this biomass to our site, how reliable is that? What are the scenarios under which all of a sudden there was a spike in the cost of biomass for whatever reason, every sawmill in the East Kootenay shut down, then what will we do? And what we've essentially done is go with a diverse model so that actually at the site, at our preferred site that we have now under contract, it's an existing industrial site, was an old sawmill, 100-acre, very large site where there is natural gas, there is electricity, but there also is biomass. It's central to the sawmills. So stability and redundancy, I think, are the only way that we can seriously consider the biomass. I know it's kind of a bit backwards, but I think we all recognize that you have to have that the shutdown scenario, particularly with us, we're a thermal process. It takes at least 2 weeks for our kilns to start up, at least 2 weeks to shut them down. They're running at 1,000 C or 1,800 C. We cannot run out of fuel. It's just a non-starter.
That's a good question about biomass. We're talking about a break-even distance, right? The minimum, at least a minimum distance of which it actually makes feasible financial sense. What would be that distance in terms of like procuring the biomass and the resource? What would be the maximum distance you would allow for?
I think, I was talking about moving our ore about 150 kilometer. I think that's kind of the range. I would call it around 100 kilometer. There may be some ways to save on trucking costs, or if we're able to switch over to rail. Rail is really tricky in the 150, 100 kilometer range. Your onload, offload is pretty much going to wipe you out in terms of the efficiencies. As well, CP, who's the carrier in that area, is not super excited about moving trains that distance. So we can go a fair distance, but it's not like on a rail level where we can go a really wide area.
Okay. We talked about costs, and I would ask Richard to explain what is the current best practice for estimating cost of energy for the mining industry. How do you estimate those costs? So you've talked a little bit about the wind and all those costs, but just maybe give us a heads up as to how you do this estimate and evaluation.
Well, at this stage, we're just using At this stage, we're just using very broad principles. I mean, we're getting guidance from the energy storage companies and the wind companies and putting it into a model. So it's no different than modeling anything else. I mean, the parameters are the same, basically. What's your efficiency? And what's the cost impact on the project at the end of the day? I don't see any difference at all.
How do Catherine, the energy cost assumption impact the investment profile of a new site? Is that something you've had to deal with in the past, and how does it impact selection?
Yeah, I mean, absolutely, because there's, especially when you're dealing with a remote site such as ours, and you're looking at costs north of 35 cents a kilowatt hour, depending on how costly it was to bring the fuel and that kind of thing. Absolutely, and that's been a killer for a lot of projects in the north. And so, and currently it's, so this, you know, the progress that people are making with respect to Diavik and Raglan, what we've heard about here today, and their application of wind technologies in the Arctic is hugely important, not just to the mining industry, but also the local communities and things like that. There are some other things to look at. People have looked at the opportunities around biomass. There have been some small pilot plants and things like that. Again, that's to touch on Tony's very important point about reliability. We just don't have that there yet, and so, but the cost of power is indeed crippling. So it does make sense for us to look, even for when you're comparing grid power to, and the fact that some of these renewables like wind are getting into a space where it's starting to make sense. For those of us generating our own power and bringing in our own diesel, it really, you've got to get over the capital outlay and the reliability issues, and how do you plug that in? And the Raglan team that presented here were quite right in their statement that they are paving, these organizations are paving the way to build those reliability pieces into technologies that now have to operate under extreme weather conditions. And certainly in our world with wind chills, we could be running, you know, at -70s.
Yeah, that's critical for turbines, of course, in operation. You bring a good point. You touch base on community discussion on social. I've seen in many cases where solutions were actually a combination of having the communities involved in accepting, you know, participation as much as equity participation or operation participation or work opportunities for them. So that's a very good point. Typically, what is the percentage? I guess I'm asking all of you. I don't know who wants to answer. I guess I'll come with to Tony. Typically, what is a percentage of the overall operation budget that goes to mining? I've talked to many mines, again, in Chile and Latin America, and it seems to be quite substantial. What is your cut on that?
Well, I mean, we run underground operations, so energy is different than from open pit, and our breakdown of energy costs. We spend probably about $9 million a year on hydroelectricity, on power, and then we'll spend, you know, $3 to $6 million on diesel and propane for other sources for moving ore. But so on a relative basis, that represents about 8% of our overall operating costs. The one issue, though, is if we're not necessarily increasing consumption. We're working on ways to lose less kilowatt hours every year, but our cost is maintaining or going up, and that's one of the other issues. You know, we talk about reliability of feed, but the other thing is being able to predict what your costs are going to be as they go on in the future. And we could get caught in an inflationary environment, or, you know, diesel costs go up, or if hydro costs go up, especially in Ontario.
Yeah, in
It's hard to
Ontario,
manage.
and in some markets, it's very difficult to predict that. And I agree with your point of view. To me, what I've heard in the market, and I'm leaving that to you if you have other comments on that. I've heard much higher percentages, right? So I don't know, is that your field, Jared? For instance, is that would 8%-10% be the figure in terms of operation cost for energy?
Well, it's, again, with the thermal model, the energy cost is far higher. So just ballpark, I would say we're at probably better than 2/3 would be our energy cost, whether biomass to syngas or natural gas. Again, the price for biomass at this time is a little bit higher than natural gas. So if you ballpark them within this kind of same, relatively close cost-wise, we would look at the better part of, let's say, $100 per ton against a total cost of around 180. So I would say more than half and less than 3/4. But we are an energy-driven. It is an energy-driven process. Essentially, you're burning, whether it's syngas or natural gas. It's a straight burn. It's no different than cement kilns or natural gas stove. I mean, it's just about 16 burners in a large vertical kiln. It's just a straight burn. It's not complicated, which is why we like it, which is why we like the syngas. But our business is essentially an energy business.
It brings our discussion on the topic of renewables. I'd like to bring you guys on the topic of renewables now, and I'm going to ask Richard for his opinion on intermittency of renewables. Renewables is an intermittent source of energy. The discussions I've had with mines is always, well, not always. I think a lot of, there are cases, and there are mines understanding the concept of intermittency and how they can manage this issue against a 24/7 requirement. What is your take on that? Is there a solution? What solution would you see, for instance, for your mining operations?
Well, I think the intermittency is there anyway. We would be on a spur off the main line, so we're going to have voltage problems and all that kind of thing. But I think that the renewables actually play a critical part in smoothing that via the battery systems. So we would probably have battery systems irrespective of which model we decide to go with at the end of the day in terms of smoothing out those power surges. But you know, the other thing that's interesting about looking at renewables at this stage of a project is what other things of the project need to be changed to make the renewables more efficient. For example, our operation in Argentina, the uranium is incredibly fine-grained. It's 5 microns. And you cannot mine that in the wind, otherwise you're going to have this plume of radioactivity. And so we've been looking, and the wind blows from about 10 o'clock in the morning to about 10 o'clock at night. So we've looked at mining during the night when it's absolutely still for those safety reasons. But the other advantage of mining at night is that only about 20%, a fifth of our power usage is actually on the mining and sieving equipment. And there's a real possibility that if we can use the wind, which is blowing during the day, and that's when the major power would be generated by those turbines, whether if we mine only at night when there's a little power draw, we can use battery stored energy for the mining equipment. And during the day when 80% of the power is required in the plant, be able to operate the plant only in the day rather than 24 hours a day. In other words, batch process. And you know, that's something that we wouldn't have even looked at unless we had been looking at the possibility of using wind power for the project. So in evaluating the economics of wind power or any other renewable, one has to look at what other things in the project can be tailored towards the positives and negatives of that alternative energy. Do you have,
like in some areas in Latin America, you have issues with a consumer, a mine in this case, not having the right or being forbidden from actually buying directly in energy purchase. Only generators can actually buy energy undergrid. Is that a case you've seen in South Africa or Ecuador for that matter? Have you noticed that? No. So you can actually buy the energy directly on the grid without having to go through a generator or breaking or contracting directly through a generator, right?
No, you can buy.
You can buy, okay. Like Chile has this issue where you kind of need to have solutions with the generator to actually buy the energy. You can't, as a mine, just buy energy. You need to be a generator to do that. So that's really interesting. What about the RPS content? What about, Catherine, the obligation to have a content of non-conventional renewable energy in the mix? In some areas of the world, you have percentages. I'm taking Chile again because I know the area very well. It's a 20% obligation by 2025. Is that something you consider when you're actually making those decisions? Is that an important factor?
It's not really a factor right now in the Arctic from the perspective of the lack of infrastructure anyway. Any infrastructure would be welcome. The things that we, in a very, very big picture, conceptual sort of models are, you know, actually getting involved with others in sort of public-private partnership, you know, the 3P partnerships for building wind farms and actually being able to, using submerged cables across to our nearest community, Cambridge Bay, looking at, you know, helping generate power for the local community and those kinds of things. But these are really conceptual and at such a high level. And so again, it's, you know, there are some really important factors to, you know, you'd like to see in our situation. We'd like to be able to take on more renewables and things like that, but we are so starved for infrastructure as it is that we've got to get started somehow. And certainly, like I said, we've inherited existing an existing powerhouse, permanent powerhouse. But these kinds of things need to be looked at. There's no question about it. And certainly the Arctic is, the climate up there is changing and people are recognizing what the impacts are. But given how hard it is to get any capital projects, including social projects running in the Arctic, you know, right now it's not part of the active negotiations at the table.
Okay. What about yourself, Tony? Do you have, is that an issue that you've considered? Is that important as part of your decision?
I mean, in terms of getting renewables,
Yes.
I mean, well, it's important in some ways is because, you know, again, you got to look at the jurisdiction we're in and what we're up to. Some of it is way to with, being responsible industry and where we're working. That's important, but we look at it also purely from an economics point of view. Is we're in an inflationary area from a power in Ontario, so we got to look at other solutions that can protect us from that. And you know, you even mentioned about the, you know, how can we use storage or you know, in terms of renewables. One of the areas that we try to manage is our peak power demand, and really the peak power demand that we have maybe this year or this day, one day in July, if we hit the peak day in July, will affect our rates in 2016. And so you're always trying to, and it's all, so you're always back looking, and so something we did today could affect us in terms of power costs in 2016. So the opportunity to use storage solutions, other sources of power, may not have to be the level that can power our whole plant and our whole operations, but they can provide a backup source or an alternate source during certain periods of time during the day when we need power to help us reduce our overall costs and what we're going to be billed at in the future is important.
That's interesting. There's two things that I'm listening to, and one is about storage. We've had the experience in storage to deal with numerous projects where you get pump storage, option with solar panels and etc. You have flywheels, you have batteries. There's quite a few options. Overall, would you say the solution is actually through storage, or is that going to be a combination, a portfolio of different renewables, or a portfolio of different energies? What would be I guess I'll ask you, Jared, what would be the solution? You think if you would have a crystal ball now and say, well, I'm going to look in the future, most likely storage is going to play a really large role, or is it not?
Well, we've looked at it somewhat. Like I said, you know, we're mainly a thermal process. So just in the concept of what the equivalent in thermal would be, it's literally stockpile of fuel. So again, so we don't run into trouble. So again, thermal process, you're going to stockpile waste wood on site. Try and keep it as dry as possible. You lose a lot of value when the wood's wet. I think anybody camping probably knows how that story goes. Not that dissimilar. In terms of electricity, we do use some electricity. We do require a crusher and ball mill to get to the kilns. The location, our site right now that we're moving ahead with in East Kootenays, plenty of hydropower. There are infrastructure issues, though. There's the dams, but the dams don't necessarily connect to the smaller towns or areas. Storage, I'm not sure that it applies to us. Really more stability of power and even getting enough power. as we would look to expand or move into other products. We are in the industrial mineral space. We're looking very seriously at silica products, silicon metal, ferrosilicon. These have massive power requirements. So the first conversation to even consider these types of projects is with, in our case, BC Hydro, and determining that there is sufficient power to even consider the plant. Again, in our case, unless we were to move to a remote site, the storage would be a secondary consideration. We look at it closely. We're very interested in, vanadium oxide and these different battery technologies. We could see in future having remote sites. We like small, higher grade or industrial mineral type projects. So we recognize the importance of the battery technology. But again, just back to the thermal model, yes, we need it, but it comes in a totally different form, not related to batteries. But still, you need to stockpile and just always have plenty of backup.
You've mentioned that in your case, I think that does not apply. You seem to manage your energy. That's, I guess, my second question to Catherine. Maybe you can answer that. How feasible is it for you to envisage the management of energy, the buying, the management of a renewable project, the storage, and all that? Is that something you'd be looking at, or would you like, or are you focusing exclusively on mining and saying, well, that's for the energy player? Is that something ultimately that would attract the mining solution?
You mean from application at our, yeah, we're actively looking at, I think storage is, like sort of touching on your previous question, I think storage is very important to us. To Jared's point, we are a remote site. If we can store store energy so that we can use it for other things for non-peak times, we might be able to even start removing some of our reliance again on diesel equipment and that kind of thing. Like it truly, storage and feasible storage at low, and the continual drop in costs of the opportunities and the technologies and their increasing application in extreme environments like ours, we see this as something that actually is closer to reality for us to try to engage on rather than anything else right now from a capital perspective, and also just the opportunity that it provides us to even run at a more efficient state and start to offset some of those other things by storing so that when we're not at peak consumption rates, we're storing energy effectively and efficiently.
I think, Richard, you had something to add to that.
Well, I think the storage is absolutely fundamental. And I think, obviously, the price of batteries is coming down. It's coming down quite nicely. Tesla's talking about $100 per kilowatt hour. And other companies are talking about prices that are less than that. But I think that it's not only up to the battery companies to drive those prices down. I think that there's an opportunity for the battery companies and the resource companies to work together. I mean, one example, and Jared mentioned it, is vanadium. I mean, we would be producing vanadium as a byproduct. It only would generate about 12% of our revenues. But from a shareholder's perspective, the revenue is far more geared to the size of the deposit than it is for anything that we get for the vanadium content. So our obligation to the shareholder is to increase the size of the deposit and increase the throughput through the plant. But there's a very real opportunity to be able to sell vanadium, which is a byproduct to us, at a discounted price, if you like, to a vanadium redox battery company or whatever vanadium technology they're using. And I mentioned vanadium redox because it's very expensive at the moment. It's about $500 per kilowatt hour. There's someone who's saying that they can get it to $300 by recycling the vanadium. If we can put in vanadium at a lower cost, I'm sure that the price of those vanadium redox batteries would come down, because all they are 2 tanks of vanadium in 4 valence states. It's +5 and +4 on the one side and +3 and +2 on the other. I mean, it's just a liquid and a membrane separating the two. So the cost of a vanadium redox battery, I don't know what proportion comes from the vanadium commodity, but it must be huge. And because it's a byproduct to us, I mean, I don't care effectively what price we sell it at. We can't put it back into the environment because it's poisonous, so we are extracting it. We would have that obligation anyway. And there's a real opportunity for us to work with a battery developer through an offtake and stabilize the price, because that's the issue with vanadium being such a huge component of the battery price. Vanadium prices have spiked over the last couple of decades. They're very low at the moment, but looking forward, you need that price stability before you commit to a specific battery technology. And the problem is as well that not only is the price moving around, it looks as though there's going to be a shortfall in vanadium production over the next 10 years. And the main producers of vanadium are China, second is Russia, and third is South Africa with its power problems and all the rest of it. So, if I were a vanadium redox battery producer, I wouldn't go near it. Well, I would be worried about getting the vanadium from those markets. I would be trying to lock in a price from someone like ourselves.
So it's interesting you talk about that, and I'm taking it in a general context of having the mine actually taking an active role and participation, maybe in a possible potential joint venture with a manufacturer of a product, in this case of a solution that could help your energy profile. I think that's very interesting. I've never really heard about this being tackled this way, and I think it's an interesting thought.
Well, I think the obligation is that all of us in this room have got to be working towards these solutions, and that's why it's absolutely critical to go through these economic analyses and say, okay, that's where the problem is. How are we going to deal with it?
Yeah. Let me ask you, maybe as a last two questions I have for you. One is actually, it's going to be the last. You talked about diesel before, Catherine, and how does diesel and renewable measure up? I mean, is this for remote operation the solution to actually go through diesel? Is there a way to actually look for some renewable solution for remote operations? I know I should be asking Catherine, but I haven't asked you, Tony, for a little while, so I'll let you talk.
Well, I mean, I think, getting back to the thing about reliability of supply, and, if you're building a remote operation, you've got a lot of things you've got to deal with in terms of on the technical side, procurement side, and money to spend, areas to spend your money on. The last thing you want to do is spend your money on something that's not a proven technology, and it might be proven technically, but it might not be proven economically in terms of being able to predict the costs, being able to predict both the capital costs and the future costs. So those are the things you got to weigh in on renewables, et cetera. So that's why, sometimes you with everything that you have to think about and all the risks you have to manage, you might lean towards, traditional power such as diesel generators. But in the long term, you can understand that these are things that can come into play as we get a better idea on predicting capital costs, operating costs, the technology, where the technology is going. Things like, as you talked about, sources of supply and demand. We're in a cyclical business. All our commodities go up and down. Vanadium prices might go up just when gold prices go down, and the whole world changes, and we got to focus on what we can do to do it traditional ways.
Hedging solutions, yeah. Catherine, maybe you would want to add to this on the remote site, diesel versus renewables from an option? Yes?
Yeah, well, actually, Tony is bang on, because that's one of the problems. And remember, for a lot of people in our industry right now starting new mines, one of the biggest issues around that, if you are not a big company and already funded, you're either trying to finance or you're trying to generate shareholder excitement for your project. And so you have to sell these products as well, or these solutions, to a financial market that may be extremely risk averse. And so if you can't demonstrate what Tony's talking about, either that you fully understand the CapEx risks or the OpEx risks and the actual technical side of those, you simply won't gain support for financing your project. And that's just a reality of, we've heard people touch on during the course of the afternoon, resistance to change within the mining industry, but it also, there are extreme pressures on the financing side. And you explaining to a potential shareholder or somebody pitching on the street or something like that, if you say cutting edge technology, they'll hide. So I think that's another thing. That actually is that is something that partly with the commodity cycle being where it is, and Tony referenced it, is that people are more gun shy than ever to take on anything that isn't completely de-risked from their perspective.
Catherine, I agree with you, and let me disagree in a way.
Okay.
In what sense? And I'll tell you where I'm going with this, and I'll finish on that. And please, let's open a discussion, and then we'll have question and answer. Renewable is not like something new technology. I mean, it's
Yeah.
been proven. It's in the market. I'm referring obviously to the obvious renewables. No, the wind, the solar, the pump storage, the biomass, and I mean those are proven technologies. Not like 10, 50. I remember this. I've been in this field for 15 years. I remember very well when we started. It was like exactly that. Reaction was, yeah, but a wind turbine. I haven't seen that. Now it's no longer like that. I mean, you're dealing with it. They're dealing with it. Everybody's kind of dealing with it, want it or not. So. May I just say as a final comment, I hear you all with respect to cost. I think is very important. Reliability is very important, and I think that the sector is just looking for the best solutions to. Yes, Tony, you were going to add.
Well, I was just going to comment and add to what Catherine, to support what Catherine's saying, though. You got to look from the investment climate point of view. And the previous presentation talked about a capital investment, and I heard some presentation say about capital investment to build power plants, wind generating plants, and battery storage to finance or to manage power costs. But if you got a 20-year payback, the other thing, the investment community has short time life. We have people, we're measuring us by quarter, and it's nice for me to put up $70 million today in a power plant that provides benefit for somebody 20 years from now. We don't know if we're going to have ore 20 years from now.
You totally agree with you.
So
Totally
that's
agree.
the other
I was looking at it from the perspective, and I didn't mean any.
We run our plants on spreadsheets.
Exactly. Yeah. But I was looking at it from an energy perspective. Of course, these things are working. So maybe I'll open the floor to some questions. I don't know how you want to do this, Adrian. If we're asking directly questions, people are coming up. They have want a mic, or can you provide a mic? I can't see you. You got like super spots here. So 3 questions. Okay. How does that work? Who's asking the question? Yes. Please go ahead.
I'm Bruno from Wisman. With Canada being one of the biggest pellet producers in the world and exporting more than 90% of the wood pellets production, did you ever consider using wood pellets for heating and hot water production?
Jared, maybe you want to answer that?
In our process, in the biomass process that we're exploring, wood pellets are the ideal fuel source. So just to comment on the biomass side of things, we like wood pellets just essentially for the stability and the density in terms of just a volumetric equation.
Okay.
Tom Albee.
Yes.
Jared, again, you seem to be very popular here on this one. I heard you mention 1,000 degrees C on your kilns. Are you doing any type of heat recovery off the stacks of those and let's say go into a reverse organic Rankine cycle or a Stirling engine recovery and pull energy off of that, or simple air-to-air heat recovery and pulling air back and preheating your supply air? Are you doing anything along those lines to reduce your energy consumption?
Sure. So there's 2 components. The flue gas, actually from the kilns themselves, goes into a preheater, and the major advancements in industrial kilns in the last 10 plus years has really been in having your exhaust gas actually go into the preheater. So you essentially have a secondary hopper where the feedstock is sitting. In this case, the magnesite ore is sitting in the preheater. The flue gas goes through the preheat. It makes a huge difference in terms of efficiency. That preheater can heat the feedstock to about 400 C, so you're well on the way. The primary energy cost, or the kind of primary thermal energy component with the magnesite actually is related to the breaking of the chemical bonds. So the 1,000-degree process actually uses significantly more energy than the 1,800-degree sintering process, just because of the breaking of the chemical bonds. The second piece, in terms of heat recovery, our partners at Highbury from the biomass side of their technology side of things are somewhat experts in this. So they're kind of looking at our kilns and our process to offload heat at minimum for just heating within the plant environment. So these efficiencies definitely make a big difference. But as I said, there's really, the main energy is just simply going for one process, and to keep that within the kilns, the heat, the energy within the kilns themselves through insulation. We're looking, for example, at using the most expensive kilns on the market through a company that has a lot of proprietary technology, simply to keep our operating costs lowest and be competitive. So we're really going to probably take it on the chin in terms of capital costs and efficiency of the kilns, but I think you recognize what the issue is if you're putting that much energy into your thermal process, it better be a very, very efficient process. Otherwise, somebody's going to do it, whether it's 2 years from now, 5 years from now, or it already is in play. They're going to do it cheaper than you, and become a formidable competitor. And essentially, we want to be that formidable competitor day one.
I think there was the last question.
Yeah, just one very quick one. Jared, I'm sorry to put you on the spot again. I wonder if you could just tell us a bit of some of the practical numbers for the gasifier. You know, what biomass feed rate is it? How big is the plant? Do you know how much? What's its footprint? That sort of practical stuff.
Sure. By energy, it's essentially kind of a one-for-one. What you're putting in energy-wise, you're essentially getting out. In terms of tonnage, to produce about 100,000 tons of magnesite, or magnesium oxide net, is going to take about 100,000, 150,000 tons of dry equivalent biomass. I'm just thinking, in terms of the other numbers related to it, I think those are kind of the big numbers. Again, the concept really is a one-for-one in terms of caloric value. Pretty simple equation. I don't really know there's too much more to it. I'm thinking about in terms of losses in the kilns and so forth. I mean, the kiln, once the syngas goes into the kiln, it's a straight burn. We're going to get probably 99%, 98%, but 90+%. But again, this is because it's a thermal process. You're creating the syngas, you're burning the syngas directly, and there is no generator involved. Obviously, once you add a generator into the equation, which is probably the more interesting subject for many of the participants today and attendees, your efficiency is going to drop off somewhat. But again, depending on the quality of your generator, you may be able to do fairly well with it. But just in terms of the straight math, there's no super equation which makes it essentially much more efficient than any other thermal process. It's a bit of a wash. It's just that you're using biomass and the advantages of that. And the one thing I just would add is, again, in BC we have a carbon tax, so this is significant. Of the approximately $180 per ton we're looking at in processing cost, we would look at about $11 per ton natural gas. So $11 per ton carbon tax on the natural gas. So these things are significant, and I think in the areas in the countries where you have a carbon tax, or there's carbon tax on the horizon, this needs to be factored in. I think the old-fashioned model where just you look at it at the end of the day has to be looked at day one, and also just where the political will is and where things are moving. We're building a plan for 20 years, 40 years. Will there, for example, be a carbon tax on off gases, in British Columbia? There's already a carbon tax on fuel and fuel burned. They don't really look at the off gases, but we produce a significant amount of CO2. We're trying to sequester or otherwise reuse that, but it's significant. And how will this tax situation work? So that fits into the equation as well.
Thank you very much. So that's the end of the panel. Thank you. I'd like you to give a great round of applause to our panelists. Wish you a great day.
Thank you very much, Jean, Tony, Jared, Catherine, and Richard. That was a great conversation. I just wanted to mention